In this lesson, we will learn to define oxidation and reduction in terms of a gain or loss of oxygen or hydrogen atoms. In every oxidation and reduction, there is a gain and loss of electrons. In some reactions, it's harder to see this gain or loss of electrons, and we can also look in terms of the gain or loss of oxygen and hydrogen atoms. Note that the suffix ation means to add. So when we're looking at oxidation, we're looking at adding oxygen. This addition of oxygen can occur from increasing the oxygen atoms or increasing the number of bonds to oxygen. And we may also see the loss of hydrogen. So if we see the gain of oxygen and or the loss of hydrogen, either of those indicates that the oxidation process has occurred. For a reduction, we will see the gain of hydrogen and or the loss of oxygen. This can mean a decrease in the number of oxygen atoms present or a decrease in the number of bonds to oxygen. We will use this process when we're dealing with organic and biological reactions. Whenever we're looking at inorganic reactions, we always want to assign oxidation numbers to each atom. Let's look at a couple of examples. Note that organic and biological reactions may only show the oxidation or the reduction process, but know that both processes are happening at the same time. In the first example, we're going from an alcohol to an aldehyde. The first thing I'm going to do is write in my hydrogen atoms on both molecules so I can see how things change. I notice that we gain a bond to oxygen in going from a carbon single bond to an oxygen to a carbon double bonded to an oxygen. And I also see that we have lost hydrogen atoms. Therefore, this is a process will be considered an oxidation. There is a corresponding reduction process, but it is not explicitly shown here. Next, we see an alkene being converted to an alkane. Again, we draw in our hydrogen atoms on both molecules, and we see that we have gained hydrogen atoms, and therefore this process is a reduction. We only gained hydrogen atoms, we did not lose oxygen atoms. You do not have to have both processes occur in order to have an oxidation or a reduction. The presence of either one of them will indicate what has happened. Identify each process as an oxidation or a reduction. For number 1, we go from a double bonded O to a single bonded O, so we have lost a bond to oxygen. We have also gained hydrogen atoms. Therefore, this is a reduction reaction. In number 2, we go from an aldehyde to a carboxylic acid. So we add an oxygen atom. Therefore, this is an oxidation reaction. In number 3, we add an oxygen atom, which means we have another oxidation reaction. Let's complete this table to summarize the changes that happen in oxidation and reduction. In looking at electrons for an oxidation, we will always lose electrons. A reduction, we will gain electrons. For an oxidation reaction, when we look at oxygen and hydrogens for organic and biological reactions, we will see that we can either gain oxygens or lose hydrogens. For a reduction, we will lose oxygens or gain hydrogens. Note that we will always gain and lose electrons even if we are not explicitly writing out the oxidation numbers of each atom. The transfer of electrons is always happening in a redox reaction. Sometimes we will see one or both of these happening to indicate that an oxidation or reduction reaction has occurred. To help you keep oxidation and reduction straight with respect to oxygen and hydrogen, remember that ation means to add. So oxidation means to add oxygen. If we know that oxidation is gaining oxygen, it must also be losing hydrogen, which is the opposite, and a reduction is the opposite of both. We lose oxygen and gain hydrogen.